the Ironman Mark 42 back brace. I made it a little differently. Notice I have not disconnected the tie, which goes around the back of the neck. This is the back part of the back wings. And this is made as a tuning fork. So that's just the wing to vibrate. This is the separate segment of the armor. This enables magnetism through a coil that should be bearing underneath the rings of the back. And it's supposed to fix like that, separated. It's a double zigzag. It's actually a zigzag multi-tuning fork. And I don't know how many hertz because I have not tried it in oscillations yet. I'm making it into electromagnetic, and this is diamagnetic. I'm using aluminum and iron. Iron is underneath aluminum. This is the aluminum frame. It's like a turner. I'm turn it upside down. Excuse me. Here I have a coil bearing. Coils local onto the fork. See, this is a tuning fork that is spread in an angle. Excuse me for coughing. Spread in an angle with a long beak. This is for as far as the vertebrae. The permanent magnets are fixed alongside here. These are nickel neodymium. They are 4.2 kilograms. And it oscillates, of course, the induction within the oscillation. And I'm still limited to, I have applied coils here, a coil here under this bearing right here. This is localized for the magnetism under the wing, this part of the back of the brace. And I have a cut right here for a coil bearings to fit around alongside here. And that will cause magnetism, should cause self-repulsive force against the aluminum that is alongside it. So move it up into the bearings are returned. So the oscillation is a return oscillation. I'm going to be using magnetism and its weight and aluminum block that they interfere to be the oscillator brace. So this is a tuning fork this way, and the other parts, that's a tuning fork that goes up, and that tuning part goes this way. So notice how the tuning part goes this way, separating this part and this part. The resistance is here for the no feedback, and the loop is for the neck to allow the tilt, and the neck being like a belt latch with a central armature that allows it to rotate for panning and tilting. So tilting forward and being able to turn left to right. So that will enable that part of the segment. I am going to add a ball bearing joint to allow it to rotate, to have freedom to rotate. However, the coils that is going to be localized, it will allow it the electromagnetism to move the armature. I'm going to be using a copper in the presence of the aluminum, and it's going to be within this iron tuning fork like latch, and it's going to be bearing right through here to this part that fits out to that segment up there, and that will allow it to tilt forward. This is the inside of the copper. And I'm not finished with it. I have still more structure. So when you see those gray parts between the armor of the segment, you're going to find that these parts right here are electromagnetic. And what they do is, under here, the following one, there's supposed to be another piece of metal that goes over here that's supposed to overlay that part a bit, so that the electromagnet bar right here, the electromagnet bar right here, but the extension that overlays will cause magnetism because the coil bearings should be on here. Then it will flux the density to cause it to stick together, to hold in a solenoid hold sense. However, this part right here, through here in oscillation, will cause induction, current carrying. Thus, how this works is not facing the coils at all. It's facing the iron bar. So the iron bar is faced with a cathode, and a part is faced with the anode. When a charge is made through a metallic bond, a phase right here to positive and phase right here to negative, at the same time while the permanent magnets are fixed onto the surfaces, which causes electromagnetism. Electromagnetism in a broad vector and a wider wavelength, and that should flux the density to the aluminum. However, I'm going to have a series of aluminum coils alongside the aluminum to increase the flux, so for repulsive force for levitation. However, this is similar to the magnetic train. One of the guys on YouTube used a coil, and they use a battery, and they use two permanent magnets for the cathode and the anode of the permanent battery, and they put it through the induction, whereas the flux in the magnet also fluxes the electrons into the battery and causes it to flow through. So in similar manner, the flow through the copper coil with the winding energy was fluxed and carried it through to escape the repulsive force through the system. However, similar likenesses of this device, when fluxing the iron, and the iron is coupled to a coil, and the magnets, permanent magnets, are coupled to the iron. So if I flux the density, increases the flux to the coil and the flux to the magnets, a broader field, a vector field. Thus, at the same time, having coils, pancake coils localized on the side of the wings, which will also flux the density to the wings and create electric flux. As long as I do not flux direct current to the coil, that will increase the flux. So when I'm fluxing this part, which is the electromagnet part, which is the iron, that I only need a cathode and anode at both ends. So a single phase rectifier diode, which is a one-way single phase rectifier diode. And then I'll use a one-way phase single rectifier diode for the anode. So one for cathode and one for anode at both ends of the metal. So both ends and points of the metal. And how you determine that is determine that by the thinness of the end point of the metal, whether rectangle or deformed. So therefore the two anodes will be here, and the one cathode here. And the anode here, and anytime it's a separate part, right here, the anode and the anode of the cathode here. And that will electroflux the iron. However, the coil is going to be alongside the iron and electroflux the coil. And a permanent magnet is going to be present within that. So to increase the electroflux of the magnetic field wavelength and repulsive force against the aluminum that is localized within a millimeter away, or local to the surfaces, into the air. So the oscillation back and forth will create the flux. While it oscillates back and forth, will create a flux. And I just have to move it away a little bit. It will create a flux through the oscillation, and that will create a flux in the electromagnetic coil, and cause it also into the air flow like a generator. So this is how the vibranium functionality probably works. So my name is Jermaine Warren. This is my back brace for my Mark 42, and I will continue working on it and show you the rest tomorrow or another time. Until next time, goodbye.